This is Pong on the Arduino, and today I'm going to show you how to make it.
So overall, our code for this build is going to be pretty straightforward as far as the logic goes. So with Pong, you have a player paddle, the ball, and the opponent's paddle. Okay. The player paddle can move upwards and downwards in the Y position. It can't move in the X direction. Can't do that. The opponent paddle, let's label these. P1 op. The opponent paddle can move the same way, up in the y-axis, down in the y-axis, but it can't move in the x-axis. Can't do that. Our ball, however, can go up, down, right, left. It can go in pretty much 8 directions. So this we will model. This will probably be the hardest thing for us to model. This guy, super duper easy. I know we plugged in a port for our X on our joystick, but honestly, we won't need it. All we need is the joystick Y value. I believe that was from analog 0. Okay. And then this guy, we're going to make it follow the position of the ball in the y-axis. So if the ball goes here, our paddle should move to get to the same point. That being said, I don't want it to follow directly, because if it does that, there's no chance for the player to win. So we're going to modify this with random. So with random what? With random speed? There we go. So we're going to modify that with random speed. So the ball will start in the middle, and we will, I believe, go toward the player first, and then the player bounces the ball. It goes toward the opponent. The opponent bounces the ball, goes towards the player. And for this, I don't think that we'll have a score system. I don't know if the OLED can handle that with the memory. We can certainly try in a future video, or maybe in this video if I'm feeling plucky. But this is the overall idea for the Pong code. Now, what's really interesting is that the original Pong was built all through hardware, which I think is really cool. But enough jibber jabber. Let's talk about our code. So first things first, let's get our breadboard set up. I do the breadboard first because connecting it to the Arduino is usually very straightforward afterward. So I'm going to do a very simple thing. A build today, we're just going to put the OLED directly on the breadboard. Okay. So whenever you're looking at your OLED, in case you're new to the OLED scene, let's see if we can focus. We have our ground right here. We have our voltage in. It's a 5 volt. We have our system clock and our system data line. So the clock and the data line, they'll be hooked up to the analog side of our Arduino, whereas these guys, I'm just going to plug straight into the ground and power respectively over here. All right, as for the joystick, I haven't found a nifty way to plug it in yet. I mean, this kind of works, but I don't like it. So we're just gonna have it be a loose joystick, all right? So it'll just be like this. We'll just play our game like this. All right. So I got into the idea of gaming on our Arduino because I was like, man, that's completely impractical, right, in every sense of the word, but it's also kind of cool, you know? It's such a niche thing to do. All right, so all I'm doing right now is I'm just putting my power to my positive ray. Oh, let me get in screen, that might help. I'm putting my power to my positive right here. That's our voltage in. Okay, am I in voltage in? Nope, I'm on the ground. There we go. Good thing that I'm not plugged into power, right? All right, so then, let's see. Take this guy. That one goes into the ground, and then we'll plug that into, here we go. I got a new camera mount and a new camera orientation, so just kind of, I'm just trying to stay where I need to be. So if I go off screen a little bit, sorry about that. All right, so there's our first setup done. Cool. Now all we need to do again is our joystick. So let's see. I'm gonna use this set of cables I've been using. They are male to female cables. One end is male, the other end is female. And I'm just going to slide them like this right onto our pins. So on our pins, so we can get this light to help us out a little bit. Maybe. Or maybe not. There we go. All right. So on our pins, you can see that we have our ground, our 5-volt, our x-axis, and our y-axis, and we have a button for this very last one. I never use the button. I mean, it's just a button, so it doesn't hurt it. It doesn't affect it if you don't put a wire to it, because I mean, there's no current running to it anyway. What I'm going to do is I'm going to differentiate my ground and my 5-volt using two different colors. So I have a tan one and a black one. The tan will go to the ground and the black will go to the 5-volt. It's not my preferred coloring convention, but it's sticking together and that's all I care about. Okay. So we're just gonna, not like that. There we go. Just gotta put it on like that. All right, so now this is my ground, this is my 5-volt, and these guys I'll figure out as I go. All right, so I'm going to plug my ground into ground, and then my 5-volt into 5-volt. So ground goes right here. Oh, maybe. Ground goes right here. 5-volt goes right here. There we go. Now the hard part's done. All we have to do is wire this to the Arduino. All right, I'm gonna scoot this guy over here, and let's loop these guys under. All right. So I'm going to plug my, let's see, I believe this is my y-axis. It's going to go into my 0, my analog 0 right here. The numbers are worn off on the side. I know it's analog 0 because I have used this board for a while, as you can tell. But also, if you look on the board, so we can get our lighting right, you can see that on the board it's actually written A0, A1, A2, A3. So that's nice. All right, so I'm gonna put my, oh goodness, I'm gonna put my Y cable, which is my leftmost cable, on A0. Ooh, that was, eek. Put my other one, my X cable, on my A1, so it looks like that. And it kind of nicely, it's ergonomic, you know? It's nice. I can go over as I need to. So now all we need to do is connect our OLED clock and our OLED data line. I wonder if I can, if you hear snorting in the background, I don't have a gremlin, I have a dog. She's kind of a gremlin, but she's my gremlin and I love her. So that's what you're hearing, if you hear snorting in the background. All right. Sometimes she whines because she doesn't like me recording videos because I'm not spending time with her. And I'm like, I get it. But anyway, videos must be made. So I'm going to use an orange line. Let's see if this will reach. I'm gonna hook it up to my clock, And then we're going to put that on our very last analog. So A5. Okay. See if we can. Yeah, A5. So these are kind of backwards. Our third pin for our OLED will go to our fifth pin for the analog, and our fourth pin will go to the fourth pin. Let's use a blue one. And we'll take this, put it right there, and then we'll just slot it right here on A4. All right. And that is all the wiring we need. Because these are modules, they have the resistors built into them. We don't have to worry about adding resistors, which is really nice. But yeah, that's the build for the project. Now let's talk about the code.
So we're gonna go ahead and write the code. Now, I am reading off my big desktop and typing the code and recording it into my laptop. So there may be some key thunkies. I'll see if I can clean it up in post. But if I can't, please deal with it. All right. So we're gonna start off by importing a library used for OLED display. Now, if you're using the online Arduino IDE, you won't have to do anything other than type include and then the library name. But if you're using the desktop IDE, go to your libraries, look up UHG2, and then install it. It's UHG2 by Oliver. So let's start. We're going to say hashtag include, and we're going to include the UHG2 lib.h. And then we're going to do some more pre-processes while we're here. We're going to define a joystick. Let's do _y to differentiate it from something coming up. Define joystick. And we're going to set that to A0. That is the pin that it's plugged into. And then while we're here, we're also going to define the speed of the AI. I said it, AI. Let's go. This video is now viral. We have AI in it. Okay. So down here on line 5, I'm gonna put some white space between my preprocessors and my constructor. The constructor is going to be used to create the object that we will use for UHG2 for the OLED. So the constructor goes as U8G2 underscore. Oh, my bad. It's in all caps. U8G2 underscore SH1106 underscore. So SH1106, that is the model of OLED we have. And then we have a 128 by 64 screen. That's the size of it. We have no proper brand name. We're going to use flash memory. It's hardware. And we're using the I2C protocol. All right. And then we're going to do our object constructor, our object actually, UHG2, and give it some parameters. I believe these are the resistor, and I'm unsure what the second one is. I'll look it up whenever I feel like it. As of now, it doesn't really affect how I code it. It's just in everything that I code, so I'm not too worried about it. So the one I don't know what it does is U8X8 pin none. Like I said, I'll look that up whenever I feel like it. All right, so that's it for the object and object constructor right here on line 5. So then we're just going to set up a whole bunch of ints that will define our paddle width, our paddle height, the size of the ball, and the speed of the ball, and the location or respawn of the ball. So we're going to do that in groups using multi-line declaration. So let's say int. We're going to start with the paddle width and paddle height. Let's say the paddle width is 4 pixels, or just 4, and the paddle height is 20. Now these are going to be used for the OLED display. They will be displayed to the OLED using the UHG2 library and some of the built-in functions with that. So then let's give the ball a size. So we'll say int ball size, and we'll make that 4. And then int paddle 1x. Oh, I put an exclamation point. Paddle 1x. Let's do a capital X. We're going to say that that is at 10. And the paddle 2x, which will be the AI's paddle, We'll put that at 114. All right. So then we have the paddle Y. Let's do our paddle 1Y to be 32. And our paddle 2Y to be also 32. They're going to be the same height or the same length. Whichever term you prefer. It's the same thing, just different dimensions, right? It depends on how you look at it. So 32. All right, and then we're going to have our ball Y and ball X, or ball X and ball Y. Let's say ball X is equal to 64. So it's going to be roughly in the middle of our screen because 64 is half of 128 on the horizontal axis. And then ball Y is going to be 32. That's the middle on the vertical axis. And then our ball speed. So we'll say our ball speed in our X direction is 3. Ball speed X equals, I'm so bad at typing, y'all. Ball speed X equals 3, and ball speed Y also equals 3. There we go. You guys remember that channel, equals 3, Ray William Johnson? Ah, fun times. Back when the internet was good, right? So this is just, I just had a stroke. This is going to ensure that our ball moves at the same speed, X and Y. All right, cool. Now I have refilmed. This is like the 5th time I've recorded this code because I keep messing up. So whenever you set up your code initially, it will have the void setup and void loop functions in here already. I just cleared everything because I wanted to start with a blank slate. So we're going to bring back our void setup. Now, void in a function just means that it doesn't return anything to the overall code. It is a void return. All right, I'm gonna enter down a bit. I love my white space, so. All right, so we're just gonna start by saying our pin mode. Let's put we're going to define joystick underscore Y, not define, you know what I mean. We're gonna say, hey, is joystick underscore Y, and it's gonna be an input. There we go. And then we want a little bit of randomness on the AI paddle, because how we're going to do it is our AI paddle is going to follow the Y orientation of the ball. And so we want a little bit of randomness on the AI paddle, because if it follows it true, then we'll never win, because the ball Y value will always be equal to the paddle Y value, and it will never miss. We want it to miss a little bit, so we're going to introduce some randomness into it by using the random seed function. And we'll say, hey, you're going to read the noise off A0. At least I believe it's reading the noise. If I'm not, correct me in the comments. Be nice about it, I'm sensitive. All right, so finally, we're just going to say U8G2 dot begin. There we go. Look at that. Okay, so this makes a joystick input. This creates a random seed. And this starts communication. Let's say it starts comms with Oled. Easy peasy, lemon squeezy. All right, that's it for the void setup. Now let's go to the void loop. The void loop. Whoops, there we go. All right. So in the loop, we're going to create an integer. Let me tab over. There we go. Make our code nice and neat. We're making an integer, and we're going to call it joysticky, all lowercase, except for the Y at the end. There we go, to differentiate from joystick Y, because what we're going to do is we're going to store the analog value of joystick underscore Y here. Now, I've ran this code already. Spoiler, it does work. But what I'm curious about is after this, and I show you the result of it, I'm curious if putting float here will provide more accuracy than putting int here. So that'll be something I look at in the future. This just it gets the value of the joystick wherever we move it in the positive direction or downward towards 0. All right, so now that we have the value of the joystick, let's go ahead and map it to the paddle on the screen. So we're going to say paddle 1Y, which is this guy right here. Right here, there we go. So these are the starting positions, 32 and 32. But we want paddle 1Y, whenever we move the joystick, to be equal to a value related or proportional to the position of the joystick. Here's a graphic. Okay, so we're going to say paddle 1Y is equal to the map function. And what we're going to map, joystick Y, joysticky, we're going to say, hey, our minimum value is 0, our maximum value is 1023, as is the maximum value of a joystick read. And then we're going to say 0. We want the minimum value it's mapping to be 0, and the maximum value it's mapping to be 64. 0 is the, I believe, top of our screen, and 64 is the bottom of our screen. But that's not good enough, because if it goes down to 64, then we won't see but a sliver of our paddle should it go off the screen. So what we want to do is remove the paddle height. Okay. Oh, that is capital up there. So right here we have 64 minus the paddle height, so that way the paddle stays on screen the entire time. Otherwise we get this. We're going to move the AI paddle toward the ball position. So we're going to use an if statement. We're going to say if, if ball Y, so the Y position of the ball, if it's less than the paddle 2Y plus its paddle height, divided by 2, then we're going to say that also if paddle 2Y, oh my goodness, I'm just forgetting all of my stuff. It's all gone. My brain is empty. There we go. If paddle 2Y is greater than 0, so it's on screen, then we're going to have paddle 2Y. We're going to move it upwards at a random rate of the AI speed. There we go. So that moves the ball up at a random speed within the range of the AI speed. Well, let's put a comment. Moves paddle up with ball. We'll put moves AI paddle. There we go. Moves AI paddle up with ball. So let's just copy and paste this. Because if we move up, we also need to move down. All right. So we're going to leave this part the same. Right here. That's going to stay the same. What's going to be different is we're going to check to see now if it's less than 64 minus the paddle height. So again, this is just checking to see if the paddle is on screen. And if it is, or the ball is above that, we're going to move it down. There we go. So this one we're moving the AI paddle up, this one we're moving the AI paddle down. All right. So next up, let's make the ball move. Let's throw in a comment. We'll say ball move. It's really straightforward. We're going to say that our ball X is incrementing by our ball speed X. And then our ball speed Y, same thing. Oh my goodness. There we go. How fun. All right, I'm gonna throw some white space so we can kind of scroll back up to the middle of the screen. I like working in the middle. I don't like working in the bottom. Makes me feel claustrophobic. Okay, so now let's do some ball logic, or ball logic, if you will. Nobody will. So let's make sure that the ball bounces off top and bottom walls. And the way we're going to do that, we're just going to check the constraints of the ball. And we'll use the OR logic operator to do that. So let's say if ball y, lowercase, ball y is less than or equal to 0, so it's off the top of the screen, or ball y is greater than or equal to 64, so it's off the bottom of the screen, but also remember, minus the ball size. Oh, ball size. We're just going to reflect that ball speed. So I don't know if you can see my cursor, but if you can, let's say we have a ball coming at this speed. All that's going to happen is it's going to reflect that ball at the same speed. So it's going to be like boop, bop. I'm really good with sound effects, I know. So we're going to say ball speed y is equal to the negative of ball speed y. Cool. And we'll put our little curly brace. Not curly brace, semicolon. That's it. I'm going crazy, y'all. It's happening. All right, so that's just to keep it on the screen with the top and the bottom. Obviously, we want it to be able to go off the sides because that's how you score. So let's do that next. So let's say ball logic paddle. Why use many word when few word work? So if let's see. Again, I am reading off my big monitor, so if it sounds like I'm reading off a big monitor, it's because I am. So we're going to say if our ball is less than or equal to, oh goodness, where'd my code go? There we go. That's part of the problem with reading off a big monitor, right? If it's less than or equal to paddle 1, x, so the x position of paddle 1, plus its width. And ball y is greater than or equal to paddle 1. Sounds like I'm saying Padawan, like from Star Wars. Padawan, right? And ball y is less than or equal to paddle 1 y plus paddle height. So we've covered all of our paddle, essentially, all the area of our paddle. So if it's greater than that, and it comes in contact with it, which the contact, I believe, is right here. I may be wrong, probably am. We're just going to reflect our ball speed like we did right here. But this time, instead of reflecting in the y-axis, we're going to reflect it in the x-axis. So ball speed x is equal to negative ball speed x. All right, let me fix this little typo right here. Boop, there we go. All right, cool. And then, the next thing we're doing is we're just giving the logic for the AI paddle. So let's just copy and paste this. Why type what you don't have to, right? So Control C, and then we'll space tab over, Control V. And now we're just going to change it to ball 2. Because it's going to be the same constraints, except instead of adding paddle width, we're going to subtract paddle width because of this. What happens if the ball goes past the paddles? Well, obviously we don't want it to go forever. That's like you're playing ping pong in real life and the ball just vanishes. It's gone forever. So we're going to have it reset. So much like how we did with the top and the bottom code, which was right here, we're going to do the left and right, except instead of changing the speed, we're just going to reset it. So we're going to say if ball X is less than 10, just to give ourselves a little buffer on the left side of the screen, or ball X is greater than 118, again, buffer on the right side of the screen, then we're just going to put ball X, its position, back at 64, and the ball Y position back at 32. So it's just going to reset to the middle of the screen, and the game keeps going. Now, all we have to do is send all of this stuff to the UHG2 or to our OLED, as it were. So what I'm going to do is I'm going to go up here, and I'm going to copy UHG2, because I hate typing that. I don't know what it is. It's just gross to type. You ever have those words or those phrases or those bits of code that are just nasty to type? That's how I am with UHG2, dude. I hate it. I hate it. So you know what? I'm going to go so far as to just highlight this whole thing. There we go. The UHG2 dot. Can't stand typing it. All right, so we're going to say clear buffer. And this is just in case we get code, in case we have graphics on the display already. We're gonna be like, hey, that goes away, that gets cleared. And the reason for that is initially we won't have any graphics, probably, unless we have something preloaded on it, like from another bit of code. So it's going to clear that buffer. But more importantly, every time this code loops, it'll clear the buffer first before displaying what we want it to display. That way it doesn't draw over itself, it draws a new frame every turn. So on the next line, we're going to have our UHG2, and we're going to make it draw a box. This is a function that's built into the UHG2 library, which is one of the reasons why we're using it, because it is so handy. We're going to say paddle 1 X for our X position, paddle 1 Y for our Y position, and then it takes a width and a height, which we're just going to cast paddle width and paddle height. All right. Then throw it with a semicolon, and you know what we're going to do? We're going to highlight, Control C, Enter, Control V. And then we're going to correct our code. There we go. And let's just change paddle 1X to paddle 2X, paddle 1Y to paddle 2Y. Because why not? And then we're going to do UHG2.draw box one more time. And this time we're going to draw the ball. The ball is a box. It's okay. So it's going to be at ball X and ball Y. And then we're going to have the ball size and ball size for the height and the width. Boop. All right, and then finally, well, almost finally, we're going to say, hey, UHG2 library, do this thing called send buffer. This sends what we have just rendered to the screen, and it draws it on the screen for us. And then we're going to have a delay of 20 milliseconds, just so that things are a little nice. All right, let's get rid of all this white space so that our closing curly brace can come back up. There we go. All right, we'll upload it and see what happens.
So now we can see that we have our Pong up and running. All right, so there we go. Look at it. Oh, there is a little bit of fuzzies right there whenever it gets stuck between conditions. I could fix that, but it's kind of funny, and I'm lazy. So you also notice that there's no score system on the screen. That is also because I'm lazy. But yeah, that is Pong running on the Arduino with an OLED display, which I think is pretty neat. If you want to build this, I'll have the GitHub repository to the code and a circuit diagram made by Wakwi, I believe. Well, made in Wakwi, along with the code in there if you want to give it a shot. I don't know if I can do the joystick in there, but if I can't, cool. If I can, cool. Right. But yeah, Pong on the Arduino. Let's go. Yes, sir. Look at that save. There we go. All right. I'll see y'all in the next video. Bye.